Hello, welcome to day 3 of section 5.6. Once again, we're finding inverses. We're graphing the original function, the inverse function, and the line y equals x. What is different between this and yesterday's or the last days that we did? The functions are going to be a little more different. So uh, it's just that you're going to have different looking graphs when you put them in. You're probably going to want to use your calculator a little bit more to plot some of the points, all that kind of stuff. So let's go ahead and get started. The very first one, they wrote y is equal to x to the third plus 1. They didn't write it as f of x or g of x. That's okay. So we're just going to swap out our x's and y's, which is our first step. So this will become x is equal to y to the third plus 1. So since the first thing they did was cube y and add 1, we're going to undo this by subtracting that 1 first. So we'll subtract the 1 from both sides. That will give us x minus 1 is equal to y to the third. Now, how do we get rid of a power of 3? We have to do a cube root. And we're going to do a cube root on both sides of this equation. So cube root here, cube root here. The cube root of y cubed is y, and the cube root of x minus 1 just stays the cube root of x minus 1. Now, not very long ago in the same chapter, we looked at what the function, the cube root of x looks like and what it would look like if it was an x minus 1. I don't know if you remember all that or not, but this minus 1 is going to actually shift it to the right one, but this is going to become our inverse. So I'm going to go ahead and call this one f of x so that we can locate them on the graph easier. And then I'm going to call this our f inverse. Okay, and then I'm going to go to graph paper. And I'm also going to go to a graphing calculator. So if you go to your graphing calculator, let me slide that up there. Okay, I'm going to hit exit. We're going to get rid of all those. I'm going to leave the y equals x one on there because we're going to use it anyway. Okay, the first one I'm going to type in is x to the third plus 1. So x caret 3, and then make sure you arrow over and say plus 1. And I want that on my first row, so I'm going to delete that and I'm going to redo it. I'm sorry. So let's see, x to the third, arrow it over and say plus 1. That way it's going to be the first graph. It'll be the blue one just like they were yesterday. Okay, then our inverse function down here, we need the cube root of x minus 1. Our cube root key is down here above the left parenthesis. So I'm going to hit shift left parenthesis to get that to come up. And then I'm going to type in x minus 1. Okay, store it. And then we're going to draw all three of them. Now, you notice something. You notice that the red one, which is our second one, only went so far, okay? So what we're going to have to do is we're going to have to decide, does that need to continue on, or what do we need to do? So let's convert these. Let's put them on our graph, okay? Okay, looking at the blue one, okay? I know we haven't really used the trace key very much, which is this one right here. But you can use this. The bad thing about the trace key is it only shows you the closest pixel. It doesn't show you the closest value. So instead of doing that, let's see what happens if we hit graph solve. Okay, I'm going to hit the y-axis or go over, and I'm going to calculate a y. Okay, now you notice it has that one flashing. That is the one I want to use. So I'm going to calculate the y value when x is negative 1. So I'm going to click enter so it knows to pick that graph. And I'm going to say when x is negative 1, my y value is 0. Okay, I'm going to repeat. So I'm going to hit graph solve, and then I'm going to hit y solve again. And I want to know what happens right here at 0. So I'm going to say, yes, I want the blue key again. I'm going to say, what happens when x is 0? And it says y is equal to 1. So far we have a point at -1, 0. We have a point at 0, 1. Let's see what happens at +1. So once again, I'm going to hit graph solve, which is F5. I'm going to hit the F6 key, and I'm going to ask it for the y calculation for that blue graph when x is 1. And it gave me 2. Okay, so I'm going to transfer all those points. So we had -1, 0, we had 0, 1, and we had 1, 2. And then that will get us the curve of that blue graph. So I know it goes here, here, and at 1 it was up at 2. Now we just need to make sure that your graph is doing the same thing. So we're coming up to this point and then up like this. There's the blue and there's mine. I'm just going to keep drawing this on up. Okay? Now we're going to concentrate on what happens. Because remember, when you find an inverse, y becomes x, x becomes y. So what that means is if you have this ordered pair at -1, 0, 0, 1, and 1, 2, then these were all using f of x because it was the blue graph. When you do f inverse of x, these should all flip over. So what that means is you're going to have a point at 0, -1. You're going to have a point at 1, 0. And you're going to have a point at 2, 1. So I'm going to plot those new points. 0, -1 would be here. 1, 0 would be here. And 2, 1 would be there. I'm going to go back to my graph. I plotted that in the wrong place. 2, 1 would be here. Okay, so that 1, 0 that we have is this point coming up like this. Okay, I'm going to have that guy hanging out for a little bit. Okay, I'm going to go ahead and plot my y is equal to x. So here's 0, 0, 1, 1. I guess I should have left that dot, so I'm going to use it now. 2, 2, 3, 3, 4, 4, 5, 5. I'm coming down here to -1, 1, -2, -2, and so on. And we'll draw that dotted line. Okay, now let's test this point and see what happens there, okay? Because the graphing calculator showed that it started here. It doesn't have anything past that, okay? So let's see what actually happens. So this is when x is 0. We're supposed to get a y value of -1. So let's plot that in here, okay? If I put in 0, 0 minus 1 is a -1. The cube root of -1 is -1. So this point is supposed to work. So we're going to look at how it reflects across the axis. So if it curved like this, then we have to sort of curve like that. Okay, whoops, I need it to come out the other way, like that. And then it's going to go on across this line. Now, let's see where some of those points should have been, okay? Because if we want to know, then we can come in here. Let's pick, I'm trying to think of a number. Okay, let's try -7, because that will give us a -8 inside of there. Okay, here's what I mean. If I pick x is -7, -7 minus 1 is -8. And if I do the cube root of -8, it should be a -2. So if I come over here to -1, 2, 3, 4, 5, 6, 7, when x is -7, y should be -2. So my graph needs to go more like that. And I'll get rid of that guy. There, that looks a lot better. And if I extend this one, you can even see. So you might ask yourself, why did the calculator only show us part of it? It's because of the way it's set up. The way it's set up to do cube roots, it only tells you the positive cube roots. It doesn't necessarily tell you the negative ones. And that's why it stopped right here. Okay, but this one was our original f of x. This is our inverse. And this is where y is equal to x. But if you're ever questioning whether it keeps on going or not, just try some x values over here and see if when you plug them into your function, if you actually get an answer that works. If it does, that means the graph's going to keep on going. If it doesn't, then maybe the calculator's right and it just stops right there. Because every once in a while, there are inverse functions that do not, pieces of them don't have an inverse. Okay, let's go on to problem 2. Move that out of the way. Okay, here's our second problem. It says y is equal to 2x squared. I'm just going to start from the get-go calling this f of x. It just makes it easier. Okay, so I'm going to swap my x's and my y's. And then I have to solve for y. So I have to get the y squared by itself first. And since they multiplied by 2, that means I'm going to divide by 2. So I'm going to have x divided by 2 is equal to y squared. Now we're going to take the square root of both sides because we have to get rid of that power of 2. So I'm a square root, square root. Now we have to have a little discussion. Okay, the first one we did was a cube root. Cube roots, we don't have to worry about positive and negatives. If you remember back when we very first started this chapter, they said sometimes there's two values when you do a square root, a positive and a negative. How do you know when that's going to be the case? This is when you know it's going to be the case. When the power on your y is squared, that means there's two different values that you can get. So when I take the square root of this, I will get y, but there has to be two answers for that. So I'm going to come on the other side and I'm going to do plus or minus the square root of x over 2. I did not have to do that in the cubed one because cubes don't have plus or minus, but the y ones have a positive or a negative. That means when we graph this function, we're going to actually have two parts of it. So this is going to be our function for f of x. We're going to replace this with inverse, and we're going to have an x over 2 equals f inverse of x. And we're also going to have a negative x over 2 equals f inverse of x. So we get two different graphs that we have to put on the graph. And then we're also going to graph the y equals x. So once again, we'll come back over here. This is going to be a square root function. We looked at those earlier this chapter also, but I'll go ahead and put it in here. I know most of you are going to use your calculator anyway. Okay, so I'm going to start with the first one, which is the original 2x squared. So 2x squared, store it. Now for this one, I'm going to have to enter two of them, okay? You cannot type in plus minus. It doesn't exist on the calculator. It'd be nice if it did, but it doesn't. Okay, so I'm going to go ahead and put this one on the first on row 2. I'm going to put the other half of it on row 3, and then I'll move my y equals x down to row 4. So this is going to be the square root of this fraction, and I want it to be x over 2. And then I'm going to delete that one because I'm moving him down. And now I want negative. Make sure you use your negative key and not your minus. So negative square root of fraction x over 2. Store it. And line 4 is where I'm going to put y equals x. So now it's going to be the purple line. And there's our graph. Now I know you know 2x squared because we've done quadratics for a long time, okay? But if you wanted to trace this again, you could, Okay, so, and you really only have to do one because of the whole x equals y, y equals x thing. They swap places. So once you do one of them, you can actually graph the other one a whole lot easier. So I'm going to come in here. I'm going to use that graph solve again. Hit the F6. I'm going to calculate a y value. And I'm going to calculate when x is -2. Um, you should know what it's going to be, though. But, well, let's do -1. We'll do -1. So, yes, I want the blue graph. I want when x is -1, and I get y is 2. Notice what happens. -1 squared is a +1 times 2 is 2. So my ordered pair there is -1, 2. We also know this graph already goes through 0, 0. I'm hoping that you know that already just because it's a quadratic. And I hope you also notice that they are symmetric. So if I can go over 1 up 2 to get this point, then I can go to the right one up 2 to get that point. So that means a third point is going to be at 1, 2. Now I have enough I can graph that. So -1, 2, 0, 0, 1, 2. And I'm going to draw my curve. Now I'm going to flip all these, okay? So this is using my F inverse. So this becomes 2, -1. This becomes 0, 0. And this becomes 2, 1. Now let's look on here and see if it actually hits those points. Okay. Here is 2, 1. There's the red. Okay. Here's 0, 0. And then we also had 2, -1 that hits the green. And that one will give us the top. This one will give us the bottom. So I'm going to plot 2, -1, 0, 0, and 2, +1. Ooh, that's crooked. But anyway, and then we'll have our y equals x equation going through there. Dot that up. This should be a little more flat. Yeah, that looks a little bit better. Ignore that piece. And this one should come down a little more like this. There, that's slightly better. Okay, but you can tell that it's reflected across. But this will really help. If you find at least 3, 4 points that are in your original function, trade them. Okay, so x becomes y, y becomes x. That'll give you an inverse point, and that inverse point is going to be on your graph. If you want to check, you can always plug it in. I mean, if x is equal to 2, when I put 2 in here, 2 divided by 2 is 1. The square root of 1 is a plus or minus 1. So that's where we got the plus and minus 1. If we put in the 0 that's from here, 0 divided by 2 is 0. The square root of that is 0. But since 0 doesn't have a positive or a negative, he's the only point. I realize these graphs are slightly harder than what the ones were from yesterday because they're square graphs, cube graphs, square root graphs, cube root graphs, all that kind of stuff. But seriously, if you will write your points and swap them, it will really help you with the graphing. When I come back, let me know if you have any questions you want to look over. Your assignment for today is going to be on page 282. It's 23 through 26 all. Have a good day. I'll see you when I get back.